Reverse engineering a mechanical clock, how it keeps time. Have you ever wondered what makes a mechanical clock tick? It's not just the hands moving. Inside the clock is a beautifully crafted mechanism that makes it function. In this article, we'll break down how a mechanical clock works by reverse engineering its components to understand the fascinating process behind telling time. The power behind the clock, the mainspring. The mainspring is the heart of a mechanical clock. It's a tightly coiled spring that stores energy when wound. This energy is gradually released to power the clock's mechanism. The more you wind the clock, the more energy is stored in the mainspring. As the spring unwinds, it drives the movement of the gears, making the clock hands tick. Transmitting energy, the gear train, once. The mainspring releases its energy, it travels through the gear train. The gear train is a series of interconnected gears that distribute the energy from the mainspring to move the clock hands. These gears are finely tuned to ensure accurate timekeeping. The gear train transfers the stored energy into a steady and predictable movement, allowing the second, minute, and hour hands to rotate at the correct speeds. Precision timing. The escapement mechanism. The escapement is a crucial part of any mechanical clock. It acts as a regulator, ensuring the energy from the mainspring is released in precise intervals. The escapement mechanism consists of a pallet and a wheel that works together to control the release of energy. As the wheel turns, it escapes with a distinct tick, allowing the hands of the clock to move one step at a time. Without this mechanism, the clock would either run too fast or too slow. The balance wheel, regulating time. In many mechanical clocks, especially older ones, a balance wheel works in tandem with the escapement to regulate time. This wheel oscillates back and forth much like a pendulum and controls the flow of energy released by the escapement. The balance wheel's precise oscillations ensure that the clock keeps accurate time. The final touch, the clock. Hands once. The energy has been passed through the gear train and regulated by the escapement and balance wheel. It reaches the clock hands. These hands are connected to the gears which rotate them around the dial. The second hand ticks once per second, the minute hand moves steadily, and the hour hand moves more slowly but consistently, giving us the accurate time. Why does it tick? The ticking sound you hear is the escapement releasing energy at regular intervals. It's the mechanical heartbeat of the clock, making sure each second is accounted for. Without the escapement and the other mechanisms working together, a clock would simply stop, making timekeeping impossible. Conclusion: a mechanical clock is a masterclass of engineering. Its intricate design, from the mainspring to the escapement and the gears in between, all work together to keep time with precision. The next time you hear a clock ticking, you'll know the magic happening inside. A beautifully orchestrated system of gears and springs keeping time alive. Want to dive deeper into the science behind other everyday objects? Stay tuned for more reverse engineering breakdowns.